Good. We're done, kind of, nearly. Let's start. Last session. So I will start with a little summary, so to check off if we have done everything we wanted to do. Then I have a little task for you. Basically, you will kind of put your current topic in relation to the business opportunities there are actually in Internet of Things, because I want to bring you all to the point that you could kind of sell what you have done here. If we have time, do a little bit on IoT maintenance, because we haven't done that. But we might have to move on directly to our invited speaker, because in the end of the lecture we have actually a connection to Brazil, to the inventor of the Labrador, if we actually get the internet working here. So let's kind of skip on to actually this. So please check. So if you are in an English lecture, there are always learning objectives, and I think most of the learning objective we can tick off here. So let's look at what we actually have done. So we had 12 sessions, and in 12 sessions I was supposed to bring you to the point that you can work with the Internet of Things, and then you understand the Internet of Things and can employ the Internet of Things in your own projects and for your own world. Okay, what have we done? We started with the definition of the term Internet of Things. You kind of discussed it. We had different angles, and we have seen that it's not very clear to say what exactly the Internet of Things is. So probably everybody of you has their own opinion on it and knows that there are different ways to look at the Internet of Things. And in the lab, we started with Arduino, and we started building our first Hello World Internet of Things system. In the second lecture, we talked about cloud, edge, fog, and cloud, edge, and fog computing. Okay, I got a small introduction in stories and how we can use stories to push our projects and describe our projects, and we talked about buses. In the lab, we were looking at the networked Hello World, and if this and that, and started to get to know some of the devices we had there. So we looked at the temperature sensor and the I2C display. In the third lecture, we worked with exchange formats and protocols. So especially we took then in the lab a look at co-op and MQTT, and I showed you the concept of simulators, and you started building your own simulators and saw how you can use that for testing and how they can be built in. In the fourth lecture, we looked at the integration aspect and the different layers of Internet of Things systems. And so we had a talk on Internet of Things integration frameworks, got kind of exposed to Flogo and Node-RED, and in the lab we started using Node-RED, and we started using the Node-RED GUI and the RGB LED. We had more Node-RED and Flogo in the following lecture, and we also committed the lab to using that. In the sixth lecture, we started with Project 1, boat challenge, measuring challenge, and you got a lot of to see one framework in which development I am involved, so I introduced iotempower to you, and so you used that also in the lab. Then we kind of dug a little bit deeper, so I hope you enjoyed kind of seeing an IoT framework from the inside. So that was what the lecture 7 was about, and in the lab you worked it on Project 1. In the 8th lecture, we finally solved Flogo, and I showed you more iotempower, so I showed you how to build drivers for a framework, how you can build in existing systems into another system. And we worked on the power saving. The secure MQTT is actually the next one. So we did actually Project 1 in the lab and the Node-RED bridge. No, it's actually all in the next one. Okay, sorry. Because then we started with LoRa and ESP Now and the Internet of Broken Things and how to do the secure MQTT connect, and you build this yourself in the lab. And also we started some of the ESP Now tests. In the 10 we had more ESP Now tests, but in the lecture we did a roundup of the security. We had this nice discussion where you fought us here in front, and we presented Project 2. Or I presented Project 2. We had kind of a roundup of all the sensors and actors we can now use, and hopefully filled the gaps to what there is. But I think you are at a point where you can basically any sensor actor that has an Arduino library integrate into your system. So that's pretty nice. And you kind of started solving some of these lighting challenges. So I think that's the new hardware point we took in addition. But last time we had the big present of various IoT projects, especially with a focus on artsy IoT projects. So I hope you kind of see the stretch not only in the industrial area, but that. And today we do the summary. We talk a little bit about IoT business opportunities, maybe maintenance, but have a focus on where is the future going with IoT. And as an example, we look at the Labrador project from Brazil. What I'd like to do, but didn't manage. So I would have liked to do more frameworks here, but kind of make some cuts in terms of times. So especially I cut Mongoose OS out for Flogo. I'm not sure if that was the great decision, but you have to see that for yourself. I kind of liked Flogo is a little nearer to Node-RED, so you had a more direct comparison. Mongoose is actually closer to iotempower, so it incorporates a bit more and has more the whole life cycle of the microcontrollers in there. So it might have been interesting. I would have liked to do other communication in the lab. So there's a really good framework which I would like you to still remember and keep in mind. So if you want to do anything on the wire or kind of build bridges between wireless and things that communicate on the wire, or over light or light bridges or so, take a look at Pigeon. Pigeon is a big open source library for any type of microcontroller and allows you to do things like take one wire and attach 100 devices to this one wire, and they can easily communicate with a low baud rate on this one wire with each other. You can also take LEDs and build optical connection in the same way. So that can be very, very handy if you want to support some very strange setups and have some other layers even after the fog to network your devices. Often wireless is not the only solution. So what are the advantages if you do things on wire? Yeah, you get much lower latency, and the security might actually much higher if the wire is somewhere where you can't reach it and people can't tap into it. Then we have, I bought a lot of RS485 adapters for you, and they are kind of used in solar panels and a lot in the industrial Internet of Things. They usually have an RS485 connector. Sorry, we actually didn't get them out to build our own. So my goal would have been to build our own RS485 devices to connect into such a network system, but I think Pigeon would have been conditioned to actually have an easy way to integrate them. So okay, you missed out on RS485. Usually I also have a small session on kind of what are the big players in Internet of Things, what are the big companies. You probably know that Google, Amazon, and Apple have a lot in the domestic area in the Internet of Things, but Google and Amazon are also in the industrial thing, big players which are trying to drive the IoT development. Lots of telcos in there which work in that space. So, sorry, also had to skip this one. There's another microcontroller which is used a lot in teaching, not only the ESP8266, that's the particle. So if you want to do something which comes with an integrated framework and with good cloud connectivity, definitely also take a look at the particle controller. It's very, very expensive. That's why we don't have it here. So that's why we focused on the ESP. But if you probably work in the Internet of Things later, the particle will become one of the things you're working with. And then there is, of course, we could have used something more with the Raspberry Pi Zero, but I also don't have access to this hardware here. So that's also kind of a pretty powerful but very small, hybrid thing, which is between a fog device and an edge device, and we could have done a lot with that. If we even had more time, I think I would have waited with iotempower a little longer, and I would have guided you to building your own IoT platform. So we would have actually continued over the Hello World and then really looked at all the problems you have if you just use PubSub in there, because there's a lot of things which can go wrong with the multitasking. When you see how much is still going wrong in iotempower, so if you don't talk to I2C correctly, and nearly no library does, then you have to be pretty careful in how you do the timing, and all these things would have been nice to take a closer look at. I hope you still appreciate what we managed here now. I'm actually kind of happy how much we did. But so this is kind of future work if you want to look at it. And also remember, we have in the master's program a home and building automation class that I teach, which kind of takes the focus on that area. And there we also use commercial components like the Philips Hue and Alexa and so on. So there we try to make a nice hybrid between do-it-yourself solutions and the commercial solutions we have. There's also KNX, but our KNX system is kind of a little bit in a disarray, so I don't know how the future of some of the really expensive components is here at the university. But so hope you keep your spirit open for eventually coming to that class too if you should do the master's program. So we have a little bit of time, and this is a project which is pretty close to my heart. So because my goal is it to guide you to the spirit that you might consider doing something entrepreneurial. I think, of course, it's nice to work with a big company, but I think everybody of you is pretty creative. And so maybe at least consider once in your life to trying out a project which could have a market potential, especially when you are young. Don't have to lose too much there, and then it's easier to conquer the world with something like that. So there's more than Hagenberg and Linz in this world. So this is why I would like you to Google for small startups, business opportunities, Internet of Things. That's actually a pretty good search term, but you can of course vary it and kind of look in the area. So I would like you to work in your regular big teams. It's okay, then you do maybe less articles, but still work kind of in your team, because I want you to work on your final project and kind of compare that and kind of evaluate your final projects in terms of business validity. So pick 5 articles, pick 5 hits you find with this query or a related query, and share these articles between the team members. Yeah, not everybody needs to read everything. But while you read it, see if you find 3 implemented successful business ideas in the Internet of Things. So what are the hot companies right now? I mean, so the old ones are kind of Loxone and Runtastic here in the area, but there's more coming at the moment, which you will easily find. Maybe a bit harder is name 3 implemented failed business ideas in the Internet of Things. And from there, also try to note down what are the challenges and opportunities arising from Internet of Things for small business. There are lots of big players, but especially take a look what are the smaller companies which are successful or failed in the Internet of Things space. So after that, so this is 15 minutes. After that, I want you to work on 5 minutes to discuss or let's say 10 minutes to discuss the potential of your project to be turned into a business venture. And I want, after this, to have a very quick mini presentation of your project so that at least the others know what type of projects are out there, and also for me to get kind of an overview in which directions we are. So kind of prepare an idea or an elevator pitch. I know that it's usually really hard, so that doesn't need to be polished perfect. Basically make 2 sentences which describe what your project is about, especially with a little bit of a focus that you present that to some kind of financier or so, kind of in this business sense. Also present 2 arguments against your own solution, say why this probably will not work as a business thing, and 3 arguments why you think it should work as a business adventure. Yeah, one of you in the team should present that, and of course we want to take a small record of this if you don't have enough research records yet, else you still should note it down so that you can. Okay, 15 minutes, read about it, 10 minutes, prepare the pitch, and then 10 minutes presentation. And then we should be ready for the talk. Good. So let's start rounding this up a little bit. So I hope you have some confirmation or some or found also some problems with your idea, which is great. So is there anybody whose idea doesn't have any commercial value? So is there anybody who feels, no, there's no way in hell that this can be turned into a business? No? So everybody kind of thinks there is some commercial validity to their ideas, which is great, which I think is the feeling I have too. So can you please just very quickly present yourself, so one person in each team say what is their idea about and what are the kind of problems you see in terms of commercialization and what are the potential benefits or things that confirm that this is a good idea. Can we start here with you guys? Do you have is there one person who wants to speak, or want to do it with two person? Doesn't matter. Just very, very quick. What is your team's idea about? What are the pros for actually doing it? What are the cons against you? Anybody? No, just it's fine. You can just say 2 sentences. It doesn't need to be super polished here. It's just not too much. I don't want you to talk too long about it.
Yeah, our idea is to make a smart fitness room.
Smart fitness room? Mm-hmm.
Yeah, where you have a RFID chip to unlock the door, and then you have a docking station for the RFID, and this turns all the lights on and music. Okay. And you have a heartbeat monitor, and this is all connected with an app.
It's like a kind of, so your company would kind of build private gyms which are fully automated, basically, yeah? Okay, so have you found some validation or something which scares you not to do it? What are the pros and cons for such a business idea to turn that into some valid business? Have you seen others doing something similar?
No, we haven't looked for other.
But you said you found something, or? You said you found some other similar solutions.
Not really, only the IoT, how IoT works with this, but not a solution that offers this class.
But what have you found? What type of solutions around this area? So is there a lot of business around fitness and health in the IoT scope?
It's a small community.
It's a small community. But are there successful companies? Is Runtastic still successful? Maybe, yeah? They were just bought by Adidas, weren't they?
Yes.
Yeah, so I think that's pretty. So but have you seen any failure? Any things which kind of make it hard to do such a solution?
Yeah, small customer base. Also, there are not too much users.
You don't think so? I'm the perfect customer for that.
So because you need a lot of space to make your own private gym.
Yeah, but you're right, and only person who has that space would actually do that. But you could kind of do it for gyms too. You could have several rooms in a gym. So I think your solution, because it's kind of based on the key, could totally work in a gym itself. Okay, can we hear some ideas about the vineyard? So what is your team doing in 2 sentences? And what are you trying to improve? Why would I want that? You want to get actually more out in kind of monitoring the vineyard. Do you build any solutions for controlling that remotely, or kind of seeing that remotely, or have some kind of dashboard which kind of makes... Okay. Have you found any proof that that is a valid business idea?
Yes. Smartvineyard.com.
So they offer actual services. You can actually buy that in real life. Have you found anything which kind of discourages you from doing what you do? Are there some failures? Are there some stories where people say, no, that was way too expensive to do? It doesn't make sense. No? You think, so are you doing it? Are you building the company?
Man muss es einfach nur so ausschauen lassen, wie wir uns die Lab brauchen.
That is a big part of the story, yes. That's why you have to do that too. Okay, let's kind of continue in front. What about your team?
We want to provide a greenhouse for your own home. So you can, if you live in a big city, you don't need a garden to plant your plants. And the greenhouse checks humidity, temperature, and brightness, so you don't have to put work into your plants, so they can grow without any problems.
So a self-contained city living smart greenhouse. Yeah. Okay. So it's kind of a little bit a mix out of something hydroponic container, but climate control. It's cool. I think that's pretty popular. Or there's, I think, probably a lot of. You should have found quite some success stories in that realm.
Galera is already a company that does stuff like this.
Okay. Have you found anything which discourages you doing it? Is there some kind of big no-nos?
Not really big no-nos, but it's something that everybody can do it themselves. You don't need a company to.
No, but for smart sensors and all this, I think that.
But I mean, the greenhouse in itself needs someone to.
Yeah, but okay, I think if you want to have the smart aspect in there, you need kind of such a company. Yeah, good. And what are you doing?
Yeah, we are providing a smart solution for museums where they can display all the temperatures and humidity of all rooms and of all exhibitors, and where there's also a security solution in there, so to measure if someone is getting too near to a painting, and also tracking of the visitors, so we can say in room 8 there was nobody the whole day, so probably they should change what's inside of them.
Okay. So I'll talk a little bit about the exhibition itself, so that you can get us some data.
Also, the devices are for age groups, so that part is interesting for children, that's for old people.
Do you have any, did you find any examples that something like that has been done before?
Louvre in Paris actually using visitor tracking. And also something like pitch voicing, so they know when there are noise sensors in the rooms. So when one of the noise sensors gets high pitch, then wow, that was interesting.
Oh, maybe you need to use one of the little microphones we have and measure noise level. So have you seen any failure in that area or something which you critique yourself?
Because most of the times it's a really big museum and they have enough money to make it work.
Okay, but this is then a very custom solution. Have you seen any which companies really are doing that, or is it the museum itself? The collaboration with the university?
The actual company behind the Louvre thing, I think they did it themselves, and the other things are also student research papers. But no real company that's big.
Yeah, so I think that's the issue I see is you could say I'm an IoT company. We do, for example, also these solutions, but I haven't seen ever a company which is specialized on museums. Maybe if you are kind of an event management thing, which also does it for exhibitions, maybe there is some market. Okay, thanks. I think the ideas are all pretty exciting. I would like to make a very, very quick break, but please only 3 minutes, because I want to prepare a little bit the talk we have afterwards. So you should at least know who we are talking to and what the Labrador is before we start the talk. So the guy we're talking to is called Professor Marcelo Zuffo. So please Google Marcelo Zuffo, and the university is called USP, University of São Paulo. And in this context, look what Marcelo is doing, what is his profession, but also Google for the Labrador and the Caninos Loucos. And then regarding that, well, does Marcelo play? What is a Labrador? And also Google John Hall. Does anybody of you know John Hall? You know Richard Stallman? I've heard of Richard Stallman, the inventor of the GNU public license. You know Linus Torvald? Yeah? So there's 3 names often called together. It's Linus Torvald, Richard Stallman, and John Hall. John Hall is one of the big open source kings, and he's one, you will see what his role in the Labrador project is.
Hi, Marcelo. Can you hear us?
Perfectly.
Ah, that's great. I will try to get you full screen in here. So you see some of the students behind. Maybe you can give Marcelo a wave.
Hi. How are you?
Bon dia, yeah? It's early morning, but see how much light they have there. It's summer over there. Okay, so meet Professor Zuffo, my colleague in Brazil. So he is kind of big name in Brazil regarding the Internet of Things, and you have kind of figured out already why, because he kind of builds Brazil's single board computer, and I think he might be able to tell you something about this single board computer and maybe some nice stories around it and what it means for Brazil.
Did you guys see my screen here?
Yeah, we do.
Yeah. Okay, guys. Thank you for this. It's quite early here in Brazil.
Yeah.
I have a busy day. Yesterday, we partnered with a major global manufacturer of computers. It's the same company that manufactures Apples. The company name is Foxconn.
Oh.
So we have a very, very intense day. But today I will talk a bit about future trends on IoT. I will talk a bit about what we call the cognitive edge. That is a major trend nowadays on Internet of Things. And just to inspire you guys, we can talk about the longest working computer ever. Can you imagine a computer working for more than 30 years?
That sounds pretty long.
Humanity has such kind of computer. Can you guess where are these computers?
Where? Banks? My students think banks.
No. This computer is on the edge of the solar system. Is the computer inside Discover. Such computer is working uninterruptedly for almost 30 years. Why? This computer is associated to a thing. And that is one fundamental problem on IoT. When we connect computers to things, things have a longer lifespan than computers. So that means that such computers associated to these things, they can eventually learn. When I was a boy, I read some science fiction about a parallel universe where the supposed computer I discovered during billions of years crossing the universe, it became an intelligent computer. Of course, science fiction, but a concept on Internet of Things. If you start to associate computers to things, some things, they last for years. For example, turtles. Turtles, they live for roughly 200 years. So what will happen if we have autonomous intelligent computers that can incorporate this kind of knowledge across the living life? So this kind of concept we call the cognitive edge. And that is a major trend on IoT these days. I know that you guys are in Europe. In the past 2 months, there is a lot of very key meetings on Geneva, London, Paris, where global experts are trying to discuss these matters. Yesterday, we have here at USP a conference on the future of microprocessors. And if you see the title of my slides, we are talking about RISC-V. RISC-V is the first ever open microprocessor. It's a processor that you can download from internet. And if you have a bunch of dollars, roughly $50,000, you can manufacture this processor yourselves. And you can name this processor, let's say, Uli. And this processor will entirely belong to you guys. So that is the part of the revolution that we will try to explain in the next few minutes. So I'm a director of a center here in Brazil. It's an interdisciplinary center. You all guys are welcome to join us. It's a quite crazy center. We do believe in what we call human-computer symbiosis. We do believe that the interaction between humans and computers lead to some kind of evolution. So when you guys spend hours interacting with social media, somehow you guys are co-evoluting together with computers. Because every year computers became faster, and somehow, it's hard to believe on this, humans are becoming smarter. So my center is dedicated to investigate how humans and computers co-evolve together. And they do this evolution through interaction. We interact a lot with computers. I'm interacting with you guys through computers. Somehow, I'm taking benefit of this symbiotic relationship, as well as computers are getting better. So that is we call co-evolution. And my center, we grab some very crazy people like Professor Uli, John Madog, and another guys that do believe that somehow this co-evolution context is happening. So my challenge is trying to understand the world in 2050. I'm sorry that we have some slides in English, in Portuguese, but we try to see how computing will be developed in the next 30, 40, 50 years. So at this moment, we do believe that humanity has roughly 100 to 1,000 computers per human. Where are they, these computers? Watches, body, cars, public infrastructure. And this number is growing exponentially. So every day, industry in Europe, Asia, America, we are manufacturing more and more and more computers. Just to give a glimpse, Professor Uli probably spoke to you about arduinos.
We did. And the ESP8266.
In 2 years, the Arduino company manufactured 50 million computers. 50 million. How many citizens we do have in Austria?
We are kind of 7 million or 8 million. Less than people living in Sao Paulo.
So, just Arduino, they had manufactured 5 times more computers. They manufacture 5 computers per citizen in Austria. Just one company. Just to give you guys a glimpse what is going on in this arena. So, particular here at USP, we have a very smart building, but most for that, we have a manufacturing line. We have a factory. So, part part of this global movement is how we democratize the technology, how we can do ourselves. Please do not believe that this industry is solely and only concentrated in Asia. As future citizens of humanity, you need to believe that you guys will be able to design, manufacture, and impregnate such computers with your creativity for the best of the humanity. So we do believe in fully open access computers. And our belief is so strong that we had decided to design and manufacture ourselves. That is on a university laboratory. In future, we do believe that you guys will manufacture at your own homes. Very small 3D printers will let you manufacturing small computers at home. At this moment, we have this machinery. It's quite expensive. But recently, we had purchased some small ones. We spent a couple of thousands of dollars. This machine costs millions of dollars. But with these small machines I gave in hands of students, they can manufacture a small series of their own designed computers. So that is very important for the future of IoT, because we need to have this kind of freedom. We cannot rely only on technology from big corporations concentrated in certain parts of the world, you know? Because the whole humanity will take benefit of such technology. And unfortunately, when you concentrate this kind of power on small groups of humans, they can do bad things, you know, like, for example, spying each other through computers. It happened with the president of Germany. It happened with our president. And it can happen with anyone in this room. And the only way to protect us against this bad behavior of some few humans, humanity, we need to democratize this key technology worldwide. Our vision, we will have trillions of edge computers, trillions. At this moment of the humanity, we have 8 billion humans. If we have 1,000 computers per humans, we are talking about 8 trillion computers. And we will see that happening, especially young people living in this planet at this moment. At this moment, the understanding of the humanity is that we have this architecture. Thousands of computers in the cloud, millions of the computers in the fog. What means the fog? The computers that you have in hands, your laptops, your smartphones. And then we do expect trillions or billions of computers in what we call the edge. What is the edge? Everything that exists in planet Earth, living and non-living things, tractors, windmills, trucks, ships, books, clothing, cosmetics, everything.
Marcelo,
Yeah.
just to keep track of it, we have this room, I think, for 10 more minutes.
Okay.
And so we need to at least wrap something up in between, else they will kick us out here. And we are at the end of my Internet of Things class, where we talked a lot about fog and edge, even if we have slightly different definition as you have. But I think the students are also very interested in the Labrador. So,
so let's accelerate then. So basically, what we did, based on this contest, we had decided to design and manufacture our computers. And particularly, we are emphasizing the edge computing. So we want to have supercomputers in the edge. And what is the problem of the edge? Energy. The problem of discovery, remember. So we need to grab energy, because such computers will be not on nice rooms like here. They will be everywhere outside. Because that, we have this crazy guy, John Madog Hall. John is a kind of mentor of Linus Torvalds. And in honor of John, we had created this program named Caninos Loucos. So we are the crazy dogs. And the joke is doing naming dogs. So we had designed the Labrador. This is small computer here. So basically, Labrador is a kind of edge computer that can support all such kind of concepts. Social IoT, edge clouds, blockchain. But in the family, we expand the family, we have more computers going on. Because on IoT, we have a lot of fragmentation in terms of applications. And what is important to say, we are designing also the ASICs. We call the K9s, that are the microprocessors that we're using here. And basically, we are using at this moment 2 architectures, ARM and RISC-V. We have a family. Until now, we had designed 4 series of these computers. And our standard operating system is Debian. Debian is one of the most complete Linux distributions. Debian supports 35,000 applications, and we wrote from scratch the Linux kernel. The kernel today is 4.19, and we are going towards the kernel 5.2. And at this moment, we are porting thousands of applications, especially those ones on artificial intelligence. So since our last talk, Uli, we fully ported TensorFlow.
Yes.
And we had also ported YOLO for object recognition.
Mm-hmm.
And many computer vision tools like Theano, OpenCV, OpenMPI, and things.
Mm-hmm.
So what is Labrador? We conceive our model in a dual mode, because probably you had studied the von Neumann machine. So the von Neumann machine is basically a processor connected to memory and input-output. What we did here, we had designed this computing module that is very small. It's a very powerful quad-core processor with a lot of memory and storage. And the computing module is very small and is becoming even smaller. Our engineers are shrinking the size of the Labrador, half of its size. This current version, Uli, that I need to ship to you, is half the size of the previous one.
You know
why we are designing?
Yeah. You know that I'm on Friday in Sao Paulo, yeah?
So we are shrinking every day such computers because they need to be invisible. So at this moment, what we have in the architecture is the CPU, it is the memory, and something fundamental for this computer. That is a power module. So any tension we can inject here, and the computer will be driven. And if we do not have enough energy, we can adapt the performance of the computer according to the energy available. That goes through special device drivers that we are specifically designing for such computers. So the computer will have an adaptive performance according to the availability of energy. And then we have the baseboard. The baseboard is the universe interface. We basically made available what you guys need for your purpose. Yesterday, we received a startup who is designing meteorological stations. So we're making available 14 serial ports for them. So we can adapt the baseboard on a very flexible manner according to your needs. And lastly, we are designing the Flea, that very small computer, because today we can design very small computers. When I asked my students, they said, well, we can design computers with 2 by 2 millimeters. And the problem is we cannot manipulate such computers in pockets. I said, okay, guys, let's inverse the question. What is the smallest object that you have in pockets? Well, the 10-cent coin. You Europeans, you have the 1-cent coin. I will discover that later. But we decide to concentrate in the 10-cent coin. And then we had designed this powerful computer that is a 32-bit computer with 16 sensors with the size of a 10-cent coin. And we are manufacturing 300 of such computers in 15 December, really, before Christmas. So until now, we had manufactured 1,000 Labradors, and we are distributing them away. Professor Rulli was our first ambassador. He's the first guy receiving the first board. John Madog became a bit jealous about that. That's it. We have a full support from our government, and we have support from this memory manufacturing company. Tomorrow, we are visiting them, and we are requesting 200,000 chips for the next batch. We will try to manufacture really 200,000 boards from January to March next year.
Seems like I have to come over more often next year.
Next time you can take 1,000 computers for your purposes.
Then next time we can teach this class here, hopefully based on the Labrador.
Yeah.
So I think there's room for one question. So thank you so much for making this possible. I know it's super early at your place, and I think we have a lot of catching up to do. I don't know, we should kind of offline discuss if we can meet while I'm passing through Sao Paulo.
Yeah.
But one question. You have one question for him. If you don't ask, so I will ask the nasty question. And I know you don't like that question very much, but so why do we want to use the Labrador and not the Raspberry Pi?
Oh, that's a very important question. I'm not a Buddhist, but Buddhist doesn't like comparisons. If we have the demand for 1 trillion computers, we need to have a lot of diversity and flexibility. We are trying to go beyond traditional maker boards because we are trying to define the future standards for our industry. We are a developing country. We have a very small industry. And we have millions of guys that if they doesn't have jobs, basically they will destroy the forest. So we are trying to develop these technologies in this part of the world to introduce citizens to the new economy. We have a long discussion about that, but computing could be inclusive or exclusive. Technology can isolate some humans from the modern economy. That goes to the sociology matter. So under our plan, we have the vision of training a new generation of humans in developing countries to design software and have better jobs than they have today. Since they doesn't have good jobs, they just go to our forest and destroy it. And we would like to modify this context in this part of the world. So somehow, we would like to have these technologies to protect environment and the rainforest. So different from the Raspberry Pi, we are trying to convince local industry, heavily adopting the technology for their purposes and creating jobs and convincing people, instead of cutting trees, programming computers for the best of the humanity.
I will try to help, maybe my students too. And yeah, thanks for your spirit, thanks for your time. And I'm looking forward to our next in-person catching up.
Thank you.
Please thank him too. Okay, yeah, this closes our class. The students still have a lot of project work to do. I will report back to you. There's some very interesting things happening here. And I'm looking forward to do more work with you and the Labrador. See you soon.
Thank you very much. We can talk later today because I have some news to you.
Yeah.
We had ported Ubuntu to Labrador.
That is pretty cool. Yeah, have some coffee, and then we kind of talk.
Yeah.
Okay.
Have
Bye.
a nice day, Willie. Bye.
So I hope that recorded that stuff. I have no idea, but it was a pretty unique thing for you. So where's the Labrador? Have you kind of given it around? You can also check it out in the lab again. I might fire it up, then you can see it running. I hope you like that. That was kind of a little different finish, but so guys, that's what I'm doing when I'm home. Yeah. So